Hi, Algebra. It's Ms. Walker again. We're here for lesson 4 of the first unit. You are already halfway through the first unit, okay? Hopefully things are going well, and I always want to remind you to send me feedback. Anything you think that could be fixed, I want to hear about it. So, anyway, let's get to lesson 4. I'm going to switch screens. Okay, so now we're on Unit 1, Lesson 4. Our learning target today is that we are going to be able to simplify expressions with square roots. So, here we go. First, oh, your screen area cut it off. Uh-oh. Can I move? There we go. It's in the window. Okay. Excuse me. First we have to go through this number sets. Okay? Numbers are called real numbers. There is actually a set of numbers known as imaginary numbers. That's not anything you're going to deal with soon. So when you hear the term real numbers, it can sound funny because every number is real. Not true. For this class, it is. There's 7 categories. The first category is natural numbers. Those include the numbers 1, 2, 3, 4, and so on and forever. Okay. The whole numbers, okay, are very similar to the natural numbers, except for they also include the number 0. So it's 0, 1, 2, 3, 4, so on and so forth. Integers. Integers include all the whole numbers, but they also include negatives. So you've got 0, you've got 1 and 2 and 3 and so on in that direction. But you've also got negative 1, negative 2, negative 3, which I can't fit, in both directions. Rational numbers, right, are all the integers, right, plus all integers, fractions, and ending or repeating decimals. Terminating. This is a subset of the rational. When you hear the word terminating decimal, that means an ending decimal, which is a rational number. Repeat, this would be, an example of this might be 2.36, something that just ends. Okay? A repeating decimal, like 1/3, goes on forever. We're at 0.3333, it continues to go. It's denoted as 0.3, and it's a bar over whatever number repeats itself. Finally, the irrational numbers can't be written as fractions. There we go. For example, pi, right? There's a number e that is irrational, and a lot of times the square root of 2 was the first ever proven irrational number. In fact, the guy that proved that the square root of 2 was irrational, it was on a ship, he was thrown overboard because they did not think irrational numbers existed. So, to put this in picture form for you, oh geez, nothing's fitting on the screen today. Oh, that's not what I wanted to do. See if that helps. There we go. So, to give you a visual, the real numbers, right, consist of all of the number terms we've just talked about. Rational numbers are the biggest subset. It includes all the integers, all the wholes. The natural numbers is the smallest subset of the real numbers. And then irrational numbers are their own section, right? All the natural numbers are whole numbers. All whole numbers are integers, and all integers are rational numbers. However, irrational is the group that stands alone. Moving on, we're going to classify these numbers. The first one is 5. Okay? 5 has a lot of classifications. It is a natural number. It is a whole number. It is an integer. And it is rational. It is all of the above. Okay? Negative 32 is an integer. It's not natural or whole because it's negative. So it's an integer and it's a rational number. The square root of 2 is an irrational number. And 7.6 is what we call a terminating decimal. Terminating decimal. I think I have that spelled right. And it is a rational. We will continue to use these for the entire year, so getting used to this vocabulary is very important. Now, a number multiplied by itself to find a product is called a square root. A perfect square is a number with a square root product that is a whole number. Okay? Perfect squares. Every number can be square rooted. I don't think that that's not true. You can still take the square root of 7, it's just not going to be a whole number. The ones that will give you the whole numbers are 1, 4, 9, 25, 36, 49, 64, 81, and 100. There's many more, but these are the first ones. Between 0 and 100, these are the first 10 perfect squares. So, move this back into view. There we go. Finding the square root. The square root of 49 is 7 and negative 7. That's important. 7 times 7 equals 49. Negative 7 times negative 7 is also 49. The square root of 25 over 81 can be written as root 25 over root 81. This way we don't have to do that division within the square root. So it's plus or minus, positive and negative 5 over 9. Negative square root of 9, right? Square root of 9 is 3 or negative 3. That negative implies specifically negative 3. Square root of negative 36. This is no solution. You cannot take the square root of a negative number. Nothing exactly times itself will be negative, because the only way to get a negative number through multiplication is to multiply a positive and a negative number. As part of an art project, Katie will need to make a square covered in glitter. Her tube of glitter will cover 13 square inches. What is the greatest length each side of her square can be? So, we have a square, or something that resembles a square, and our area that we can cover is 13 inches squared. Now, since the side lengths of a square are always the same, x times x, I find this out by taking the square root of 13 to find out exactly the side length I need. So pull out your handy dandy calculator, find the square root of 13, and I get 3.6 when I round. So my answer, right, what is the greatest length each side of our square can be? It could be 3.6 inches. So our learning target today was that students will simplify expressions with square roots. Knowing the number categories is what we did today as well. That is important as we move forward with learning what numbers we can use for solving square roots. Okay? If you have questions on anything, go back and watch it. I went a little fast trying to stay under the time limit today. And pause if you need to. And make sure to write down any questions, take notes, and come prepared for class tomorrow. All right, catch you on the flip side.